For 4.4, we're going to be talking about polygons in the coordinate plane. And remember that the coordinate plane is going to have an x and a y axis. And I'm going to try to give you the option to have some grid paper that's already kind of pre-drawn and pre-labeled, or you can always use graph paper, or in a pinch you can certainly sketch out a rough coordinate plane in your notes if you're just using line paper. We'll try to find the best use for all those options, and we're not working towards perfection, just a general idea, and making sure we can graph accurately. But here you're going to remember that you can use ordered pairs, and remember that's going to look like an x and a y in parentheses here, and the x coordinate will always come first, and that, remember, is going to go side to side or horizontally, and then that y coordinate is always going to go vertically up and down. So we're going to have to remember to plot correctly, and we can use those ordered pairs to represent vertices of polygons. And vertices is a word in this case that basically we could swap out for corners, but basically the vertex of an angle is the corner point. So for instance, if this is an angle, this would be considered your vertex. And when you have a polygon, for instance a rectangle here, then you would have several of those vertex, and the plural is vertices. So these corners, all of those would be considered your vertices. So that's just a vocabulary piece that we'll be getting used to using throughout this section. For example 1, we're going to be drawing a polygon in a coordinate plane, and you're going to write your directions down here first. The vertices, which we just talked about there, remember those are the corner points, of a quadrilateral, so remember that means we know we're going for a four-sided figure, are, and then here are your vertices. And the capital A, B, C, and D are what we're going to name each one after we plot it. So the first one says 2 and 4, and remember, this first one is the x coordinate, which goes side to side or horizontally here, and the second one is the y coordinate, which goes vertically or up and down. So this first one says it is 2x on the x line, so we think about down here this being 0 in the corner, and then so this could be 1, 2, 3, 4, 5, 6, 7, 8, and we want to make sure that we label that, and then that means up here we would be going up, and this would be 1, 2, 3, 4, 5, 6, 7, 8, and you could keep going if you needed to. We've got spaces. The important thing about this is remembering when we plot for now that the whole numbers that we're using are on the marks. They're not in the middle of the boxes, and we could certainly put those in the wrong spot. We could do halves if we needed to. We could end up in the middle, but for right now these are directly on the lines. So when we're looking at 2 and 4, that means we're going to go over 2 to right here and up 4, 1, 2, 3, 4, and that means we're looking for that particular coordinate right there. So we're going to put a dot again in the corner of that box between the 2 and the 4 lines right here, and then we're going to put a letter A next to that as its label, and then we're going to keep doing that. So the next one says B is 3 for the X, so over here and up 9, and once you're sure you've got that one, then you're going to go ahead and put your mark in the corner there again. And sorry about that, my pen function's not working. So there we go. And again, we're going to put a letter B there. And then the letter C says it's at 7 and 8. So we're going to find 7 down here and go up to 8 right there and put our vertices, or the vertex, that's C. And then D says it's at 8 and 1. So we've got 8 here, 1 here, and put your mark right there. And then the key here is that you need to make sure you connect them in order. So connect the vertices in order. And so we started at A, and then we went to B. Now, I would encourage you, if you're really working hard on organization, to consider using a straight edge like a ruler, or even the edge of your paper or book would be fine. But just as long as you get it close enough is fine. And then to C, and then, oops, I forgot to label D, but that was down here. And so then we go down to D, and then we end up just connecting it back over to A. And we have what kind of looks like a kite shape. And again, it's got 4 sides, so it did work out to be the quadrilateral that they told us it would be. And that's just graphing it in the first place. It's drawing it. And later on in this section, we're going to be finding area and doing some other things with it. But for right now, you're just going to practice drawing the polygons in the coordinate plane by using the vertices that they give you there and remembering to label them if they give you a number or a letter to name them. For the on your own problems, remember you're going to again draw these polygons, so use the graph paper or the grid paper if it makes it easier, and then make sure you number each problem, the 1, 2, 3, and 4, but then as you're doing each of these, make sure you remember to label them, and obviously you should, just by looking at it, you should be able to see what kind of polygon it's going to be. So for instance, this one gives you 3 different vertices, which means that we're looking at 3 corners, so that would represent a triangle. And then these other ones, they'll give you different shape or different numbers of vertices. So this one's 4, so we're talking about a quadrilateral. Doesn't guarantee that it's going to be a rectangle or anything like that. It just means it's going to have 4 sides. And as we get used to them, you'll start to recognize patterns. And then down on this one, make sure you understand that you can graph in the coordinate plane using halves. You can still number by whole numbers. You just are going to have to maybe possibly plot in between some of your points. So it is a little bit of a challenge, but I know that you'll be able to do that. One key idea that we're going to spend some time looking at for example 2 here is that you can find distances, and they mention up here that we're talking about in the first quadrant, and a coordinate plane typically could actually be something that looks like this, with your x-axis being here and your y-axis being here. And the first quadrant would be right over here, where we normally are actually spending most of our time graphing. We don't even pay much attention to these other quadrants, but we will be eventually. But this is your first quadrant over here. And as you can see from down here, that's pretty much what we're dealing with, is that first quadrant. So when we're there, you can notice that there are a couple of patterns to watch for. One pattern here is that when x coordinates are the same, then you can actually find the vertical distance between points by finding the difference or subtracting them. And that is what we have over here. So in this case, you can see that your x coordinates are the same. You've got D and D. They didn't even give us numbers here. But then they said if your y here is F and your y here is G, that if you subtract F minus G, you can find this distance right here. And again, don't panic, we're going to get lots of examples, but you are going to want to write this key idea down. The second key idea here is that when the y coordinates are the same, then you could be able to find the horizontal distance, again, by looking for the difference, which is subtraction, of your x coordinates, and that is shown right up here, that if you've got whoops, I circled the wrong one. If you've got 2 matching y coordinates, so in this case B, then if you just subtract your 2 x's, C minus A, and of course right now you're going to want to circle, or excuse me, put the bigger number first, which will be always the one that is farther to the right here. So you'll put the one from the right hand side and then subtract the other one, so you don't have to deal with negative numbers. Then you would find the distance from the horizontal distance between these 2 points. And that's exactly what we're going to be doing here in example 2. For example 2, we're going to be finding a perimeter in a coordinate plane. And just a quick reminder here, you can read through about what the perimeter is, because we've been talking about area a lot, but we haven't done as much with perimeter recently. So double check that you understand what all of this means, and remember we're going to be adding here. So the actual question for example 2 tells us that the vertices, or the corners, of a rectangle are, and they give us these 4 points, and they want you to draw the rectangle in a coordinate plane and find its perimeter. So the first thing you have to do is take the time to make sure that your coordinate plane is set up, that everything is labeled in equal intervals here, and that everything's on the right line, and then you're going to go ahead and draw that rectangle out just like we did in example 1, and make sure you label everything really carefully. After everything is drawn and labeled in, then don't forget to connect all of your points in order. So we went from F to G, G to H, H to J, and then you finish off your quadrilateral by going back to that original point. And you can see we've created a rectangle here, and then we're going to focus on the second part, finding its perimeter. In order to be able to do that, we've got to find each of these distances. Now I know on a grid or on a coordinate plane like this, you can simply count boxes, and you can absolutely do that as your check step. But if you go back to that key idea we were talking about, it mentioned that if you look for ordered pairs that have the same x coordinate or the same y coordinate, that you can also find the distance that way. So that's what we're going to focus on this time. And in order to do this, you're going to want to organize things a little bit. And so one way to organize that is to decide if you're going to do your same x coordinates first or y coordinates first. And it truly doesn't matter to me which you start with. There are some of both here. So I'll go ahead and start with my matching x coordinates. So here I've got a 1 and a 1, and we're going to really call these by their letter names. So F has 1 and 6, J has 1 and 2. So that means that if I focus on the difference here, and if I do F minus J, the x coordinates here, then what I'm really, or excuse me, the y coordinates here, then what I'm really doing is 6 minus 2 to find that distance, and 6 minus 2 is 4, and that tells me that my distance from F to J was a distance of 4, because there was a difference between here and here of 4, and that was because we were over the same number of spots in the x coordinate, and the only change that we had was right here. And then if we look for more matching x coordinates, we've got 2 7s here, and that means we're talking about the distance from G to H. So again, from G to H, you can kind of just put a little arrow here. It doesn't have to look like a subtraction sign necessarily, but from G to H, that means we are going from 6 down to 2, so we subtract that, and 6 down to 2 gives us a distance of 4. And again, it makes sense. It should match that other side, because by definition these rectangles should have equal sides. And then we go ahead and we look at the other matching ones, and in this case we're looking for matching y coordinates. So here from F to G, we look at that line from F to G, then we can see we're both in those coordinates 6 spots up. Those are our y coordinates, matching y's. And so we're going to focus on our x coordinates, and we're going to start with the bigger one, which is 7. And that we're going to take away from that 7 the 1, which is this coordinate right here, and 7 minus 1 equals 6. So that tells us that the distance from G to F, or F to G, doesn't really matter, is 6. And again, we said F to G, but if you forget and you put the 1 first, then you try to subtract 7, you're going to get into negative numbers. So you'll always want to put that bigger number first when you do your subtraction. And then we're going to do our last one here, and we're going to go from J to H. And if we look at it again, we should have matching y coordinates, because we should be the same distance up here. So we're at 2 and 2 in our y coordinates, and then we've got 7 in our x spot and 1 in our x spot over here, and 7 minus 1 is 6 again. So again, that distance is 6 from J to H. And what we just did is filled in the numbers for our sides here. And so these are all of the sides of our rectangle, and all we have to do to find the perimeter then is to add these for the perimeter, and 4 plus 4 is 8. And then you can group if you want to use your properties. You can do 6 plus 6 is 12, and then you can do 12 plus 8, which is equal to 20, or you can just add them in order. That's entirely up to you. But when we add them all up, that tells us the perimeter is equal to 20 units, because they didn't tell us if it was inches or feet or anything like that. So it's just 20 units. And one thing you'll remember about perimeter is that we do not use square units. We use square units for area when we're trying to find the inside distance, but for perimeter we're adding everything, we're not multiplying, so we don't square those units. And that's your final answer then. So as we wrap up for right now, the thing to consider with this one is that the organization here of labeling everything and knowing exactly which distances you're finding is going to be key when we're practicing these. And we're going to practice many more of them together during our partner work, but just make sure you've got everything copied and labeled and organized this way in your notes so that it'll make it easier to follow when we're working together.